Hello guys, welcome back to another video. So today I'm going to be explaining how to do the Mr. Pabico oscillation pendulum lab, and I'll just give a little bit of a short introduction on linearization. So if we look right here, I have my data currently put up. Um, so what you're going to need for this data is your time in seconds for the 32 beats and the rope length. And so from that, we're going to calculate the period of oscillation, which is basically the number of oscillations, which is half the number of beats, so 16, and then put the what's it called, the number of seconds, because if we think about it, um, the time period of just a linear thing is the number of seconds divided by one oscillation. So this will basically get us our time it takes to do one oscillation for each of these values. They're not in order, so yeah, just bear with me. This is just the order that Mr. Popko sent them in. But then after that, we're gonna have to you can also choose to look at frequency, but basically Mr. Popko asked to for us to graph a L versus T or frequency if you want. I'm going to show you how to do T here, which is the time period. And so basically, the reason why the L is on this side is because we knew roughly what the period was going to be due to the songs he was playing, and we were measuring what length it is. So this is our dependent variable, I believe that's what it is. I don't know, whatever. But basically, if I graph rope length versus period, you can do that by clicking Control, highlighting rope length, highlighting period, and then do Insert Chart. So it might start off with a column chart here. Switch to a scatter plot. So we can originally see a square root looking curve, but this is actually period versus length, which will give us the square root curve. And it's also demonstrated in the video that this guy, that Mr. Papico put. So to fix this, what we can do is we can switch around the axes. So now it looks more like a parabola, which is going to be our length versus time curve. So how do we represent, sorry, length versus period? How do we represent this theoretically, not in the experimental sense? Well, if we look at our relationships with angular frequency, angular velocity, whatever, omega, basically, from our calculations, we've determined that this is g over L for small angles, and that this is also 2 pi over t and 2 pi f. I'm going to only show you the way to do it with t because I think that's easier. But if we're trying to combine these two equations, right, and we're solving for t or L, basically what we're going to get is t equals, right, the reciprocal of 2 pi times the reciprocal of this over here. I'm not going to put parentheses, but it's basically flipped around. You can do the algebra, all the steps if you want. I don't think that's really necessary. So basically, we have this relationship of t equals 2 pi root L over g. And so basically, the whole point of linearization, right, is currently we have a parabolic looking graph, right? And we want it to turn into a straight line. And so we basically want that to be in y equals mx plus b form. I'm not even going to worry about the plus b though. We just want it in a y equals mx form. So if we look at this right now, this means our y is t. The mx, if we like remove all the extra stuff, right? All the constants, we could say root g. We have our m being this whole thing, and then the x being square root of L. But if we notice, he wanted us to do L versus the period, L being the length. Length versus period, so that means L would actually have to be Y. So there are two ways to do this. So if we take our same equation, t equals square root, I don't think it's that. T equals 2 pi over g square rooted square root of L. We basically want L to become Y. So there's two ways we can do this. We can flip this by just dividing everything by that. So we get root L equals, I'm going to just flip this around, T root G over 2 pi, right? But the thing is, usually I think you don't want your y value to be a square root of something. Personally, I just don't really like it. So what I'm gonna do is I'm gonna square it. You don't have to square it, but I'm gonna just square it to show for this video. And so basically, since we're squaring everything, this turns into L because the square root gets squared, t squared, t squared, and then root g squared is just gonna be g over 2 pi squared, which will be, I'm going to just write that as 2 pi squared because I don't want to have to think about that. It'd be 2 squared pi squared. So now we have an equation sort of in y equals mx form, right? So our y is L. That aligns with our graph, right? Y axis L. Our m is going to be the slope, so everything that's not a variable, which is all these constants. And then x is going to be t squared. So if we want a linear graph that's a line, we're going to graph L in the y-axis versus t squared. So that's basically what I've done. So in the spreadsheet, what I've done is I've added a t squared column, which is just taking the period and squaring it. You can check if you want. And I've graphed this here. I'll show you how to graph it. So again, click Control. You want to do t squared versus rope length. Insert chart. It gives us a bar chart, column chart. We want to switch it to scatter plot. So now to check what the x-axis is, let's go back to our drawing. So we want the x-axis to be t squared. You should have too many graphs out. X-axis we want to be t squared, and the y-axis, they call it a series here. That's just up and down. We want it to be rope length in meters, and we can check that by looking at this point. That point looks like 1.84, so we are good. So now, how do we get a cool line like this? So, basically, you can go to from the setup, you can click the Customize tab, go to Series, click Trend Line. It'll approximate a best fit line. And if you want to see the equation for it, switch the label to Use Equation, and we can see we have the exact same thing here now. And we're getting a slope of 0.235, and it's going to be or it's going to be different for you guys, obviously, because we have different data. But 0.235 is equal to m, right? But what else is m equal to? M is equal to this whole mess. And in this lab, he's asking us to approximate or experimentally check. I don't even know. Yeah, experimentally check what gravity is. So this is basically g over 2 pi. That's all squared. Yeah, g over 2 pi squared. And so now if we're solving for g, all we have to do is multiply 2 pi squared by that. So get 2 pi squared times 0.235. And I'm going to put parentheses around here. That's going to give us our value of g. I hope this is right-ish. 2 times 3.141 times 6.282. Okay, times 0.235. So this gives me a value of 9.27, and that'd be meters per second squared. I'm a little bit worried though, just because Mr. Pabico said the answers don't look like 9.81. I feel like that's pretty close. So just to clarify, I'm pretty sure that we're allowed to square everything here. I might have done an algebraic step wrong or something like that. But yeah, that's basically right, I believe. Um I can also check it the other way, and then I'll update if this turns out to be an illegal move, but I'm like with a good amount of certainty that you are allowed to take your equation and then just square it to get it in more of a linearized form. But yeah. So basically the slope of the line is just going to be this, all squared, and you can also try it out. I'll just like walk a little bit through what you would do if you're remaining with the square root of L as your thing. I think it was square root of G over 2 pi t. So if we're looking at y equals mx, the slope here is going to be that. The x here is going to be t, and y is going to be there. So we're basically going to be graphing on the y-axis, square root of L, on the x-axis, t, and the slope here is going to equal root g over 2 pi. So in your spreadsheet then, what you do is you do square root of L, and then you type in here equals square root, hopefully, square root of a positive number of L, which is going to be C2, and then close parentheses. And usually the autofill is good, but it's good to check it in the quarter just to see. And so now what we're going to do is we're going to graph, do another graph. Jeez, there's too many of these. Uh-oh. Okay, square root of L and rope length. Uh-oh, I clicked the wrong button. Okay. It's control to highlight multiple things. Insert chart, column chart, scatter. Um, oh wait, I'm okay. That's that's why it doesn't work. Sorry. I accidentally did it. Rope length versus square root of L. You want to do square root of L versus the period, and then insert a chart. Sorry about that. Column chart, scatter chart, and to check x-axis, we want to be period. Y-axis squared out. Wow. Okay. And then we're going to customize series, trend line, none, use equation. So now we have a slope of 0.49. So m equals 0.49 and is also equal to root g over 2 pi. 2 pi. So now to solve for g, we're going to do 0.49 times 2 pi, square that, and then I'll just see if we get the same value just to check. So 0.49 times 2 times 3.14159 is 3.078 times 3.078. We get, ooh, slightly different value. Not sure if I approximated something a little bit too much, but 9.476. Um, that's, I feel like, close enough, but also a little concerning given it is like a slightly different value than here. I might have just plugged something in wrong, but that's essentially what you're going to be doing in this lab. I guess also the best fit line would be slightly different. So yeah, whatever. But yeah, that's basically the idea of this lab. That's very linearized. Just think of it as y equals mx plus b, and then to get a straight line, see what you would put in for each. And honestly, you don't even have to worry about b in this situation. So yeah, that's basically it. I'll leave an update if this turns out to be like the wrong method. I'm like 90% sure that this is fine. But if for some reason the I did something wrong, I'll leave a update video and I'll whatever. I'll update people. I'll probably private this video. But yeah, please let me know if you have any questions in the comments. Yeah, thank you.